What is the domain and range of a function or a relation? So generally when you've got, like here I have f of x equals something divided by 0. You end up with infinity when you take something divided by 0. You get a domain error, undefined, bad things happen, the sun explodes, I don't know, things like that. G at x equals the square root of a negative something is also bad. I mean, I think it's good. It's an imaginary number. I love imaginary numbers, but it's very difficult to graph imaginary numbers. You got to have a complex plane and different things like that. But, so let me just show you how to find domain and range of just some run-of-the-mill equations. So let's start with this first one. F at x equals x squared plus 1. So we'll use GeoGebra to help us. X squared plus 1, I'll remember that. F at x equals x squared plus 1. Okay, I'm going to put this in, and you notice I have a red line and a blue line. Okay, the red line is perpendicular to the x-axis, and the blue line is perpendicular to the y-axis. We'll use those to help us determine the domain and range. Okay, so there's my function, f. And so if you move around, so let's do the domain first. So I'm going to take this line, and anywhere where that line touches a function, part of the function, that is part of our domain. So this is our x line. So if we start at 0 and go left, notice we still have a function, still touching the function. So we're clear out here to about, 2 1/4, and it looks like it disappears. Well, if you zoom out, you notice that it keeps going on forever. And if you want to just keep dragging and dragging and dragging, you can go forever and it'll never end. I'm not going to do that because that's going to take a little too long. But so we're going to go all the way left and we're going to go all the way right in the same manner. It looks like it disappears there, but it doesn't. It keeps going, it keeps touching the graph. So anywhere that line touches the graph is part of the domain. And that's in all directions, left and right. So, and you could shrink this down so you can kind of see, if we get a really crazy scale like 600, now when you drag it, you can really see that it goes on and on and on forever in the domain side. So I'll keep dragging, touches, going the other way, and the same, it touches everywhere. So my domain, so hopefully I've illustrated the point, that my domain for that function is all real numbers. Domain for this function is all real numbers. And so that's your x values. Now range is your y values, or your vertical axis. So we'll look at the same graph, but this time we'll drag the blue line. So we'll come over here, and I better change that scale back to where it was so it isn't quite so crazy looking. Because we want something happens there. Notice when we drag this blue line, which shows our range, our y values, there's nothing. It doesn't touch the graph at all down here. And it doesn't start touching the graph until you get to 1. So at 1, the range begins. And then it goes on forever going up. And again, you could move the graph around and keep going just to illustrate that point, that this horizontal line is always going to touch part of the graph. In fact, it touches in 2 places. So our range starts at 1 and goes on to infinity, in positive infinity. So my range of this function, range is the y values such that y is greater than or equal to 1. Sometimes you could use set notation, and it would be 1 to infinity. That would also work for your range. So all y values such that y goes above 1. So I don't care how you illustrate that. You could write it in words for all I care. Say The range is all y values greater than or equal to 1. You know, say it in words. You know, the symbols are freaking you out, don't use them. Write it out in words. They're just used to help us make things shorter. Okay, if you go to the next thing, and probably used incorrectly, like I probably just screwed something up with them, who knows. But the main thing is understanding what domain and range is. So let's do this x square root of x minus 5. So now in this case, square root of x minus 5, I'll change this f to sqrt x minus 5. Get rid of that 1. And there's what this function looks like. Let me zoom out a little bit so you can see it. We'll move it around. And again, oops, notice in this case, I lost my point. There's my point. Let me bring it down to where I can see it. Notice in this case, it starts at this point for domain. You know, where that is specifically, it looks like 5. Starting point keeps disappearing on me because I'm zooming in and out and around and through. Okay, so if I move that around, my domain, nothing happens out here until I get to the point 5. Then the function starts to graph. And then it'll touch everything going on to infinity. So my domain is all values greater than or equal to 5. So, and then you look at the range, nothing happens down here. You swing up here to 5, or to 0, excuse me, we're talking about the y values now. And from 0 on up, I have a range value. So that line intersects the function somewhere. So, excuse me. So my domain, again, that was the red line, that was x values. Domain, I have them writing it in blue, isn't that nice? Domain, like I say, I don't care if you use words, symbols, whatever. It's all real x values greater than or equal to 5. Okay, range for that one would be the y values greater than 0. So y is greater than or equal to 0. Or, you know, again, set notation 0 to infinity for the y values. Okay, so now how about h? Let's take a look at its domain and range. Okay, this one's going to look a little different. 5 divided by x minus 1 and x plus 3. Okay, so I plugged it in, and again, we'll find our domain first. So notice my domain seems like it disappeared, you know, it doesn't hit the function right in this area. Then it starts hitting the function again. Same here. Now here's hitting the function, then it suddenly doesn't again. And then it's hitting the function again. So there's a couple, I call them holes in the graph, and I'll zoom out so you can kind of see that. And they both occur, I'll zoom back in. Looks like one occurs here at 1, maybe. And then another one occurs at -3. I'll pull that out so you can see that. So those are asymptotes of that equation. You know, might look up what an asymptote is. But those are two basically holes in the function where the graph suddenly doesn't touch the function at those places. And how you find those, so let me go back to the equation, is you look at your denominator. Anytime you divide by 0, remember that dividing by 0 thing gives you infinity or no solution or undefined or domain error in the calculator. Well, if you set each of those to 0, oops, so x minus 1 equals 0 and x plus 3 equals 0. In that case, x would be 1 and x would be -3. And in our case, our domain are all real numbers where x could not be, except for 1, and x cannot be negative 3. If you plug those two numbers in, look what happens. You'd have 5 over 1 minus 1 times 1 plus 3. Well, 1 minus 1 is 0, so you'd have 5 over 0, because 0 times 4 is 0, which is a domain error, or undefined. And the same if you plug in negative 3. You get 5 divided by 0. So you do not have a real number in those two locations. So all real numbers work except negative 1 and, positive 1 and negative 3. If you look back at our function for the range of that one, notice my range of that one in the blue line, I've got a big gap in here also, looks like, between, and this one's going to be a little trickier, and it's probably beyond the scope of this video for finding it, but we've got some parts of this graph that don't exist in that range. And for now, we'll just, without going into any heavy detail, because I got one more I want to show you, looks like my y value of negative maybe 1.25. So from 1.25 to 0, nothing occurs. So 1.25 to 0. So the range for that one, I kind of gave you a nasty one, but usually it's all real numbers, but in that case it's not. So my range in that case is all y values greater than or equal to 0, and all y values less than, it looked like approximately 1.25. And again, beyond the scope of this video to really get to that exact number, but that gives you kind of an idea. It's all the numbers above 0 and below that 1.25. Because I want to get to this last one, x squared plus y squared equals 36, and do something similar with that. So x squared plus y squared is 36. We'll plug that one in. X squared plus y squared, because that's the equation of a circle, if you've ever seen that. And let me zoom out. I have my scale set. It looks like an oval, but my scale is really, really crazy. Let me get my scale set so it's about the same. I'll zoom out a little more. And notice my range starts at negative 6 and it goes to positive 6. And then my horizontal line runs out of graph. And same with this one. It goes to negative 6 for domain and goes to positive 6. And then suddenly I'm out of graph. So my domain is anything from negative 6 to positive 6. And my range is anything from negative 6 to positive 6. So there's an example of a relation that you can find the domain and range on. So the domain would be x values such that we'd have, and they'd be solid brackets because they include negative 6. So negative 6 to positive 6, solid bracket. Or you could also write it like this. Means the same thing. Or you could simply write the real numbers between negative 6 and 6. And then for range, same thing, but it's your y values. And again, it's negative 6 to 6. Or negative 6 is less than y is less than or equal to 6. Or again, I would just simply state, if the symbols kind of bother you a little bit, that the range is all real numbers between negative 6 and positive 6. And hopefully that helps you. Kind of a long video. Have a good one.